Welcome back to NANDGAME. We're making our way through the software section and we are up to Stack Machine, which looks like it could be a long, challenging series of levels. So let's just jump right in. Init Stack. As you may have realized, writing code using only 2 registers is very limiting. Therefore, we introduce the stack, a simple but very powerful tool. The stack is an area of memory where we can store and retrieve intermediate values in a last in, first out manner. We use the first available memory address 0, to store the stack pointer. This first exercise is to write code to initialize the stack pointer to a memory address. We write this in the form of a macro called Init Stack. A macro is a snippet of code which can be easily reused. If the keyword init.stack is used in an assembler, it will be replaced with this code. So it looks like we have to write a macro called init.stack where we set the stack pointer to 256. It may be helpful to define a constant named sp with the value 0. Okay, so we want to define a variable named sp with the value 0. Then since we're going to want to store the value 256 into the memory address at address 0, first set a to 256, and then we'll set d to a, so that 256 is stored in D, A register to SP, so that it points to 0, and now we do a star equals D. And let's check our solution. Okay, a pretty simple one to start. Let's move on. Storing a new value on a stack is called pushing. Write code which pushes the current value of the D register on top of the stack. The SP should be increased by 1. Okay, we want to start by setting A to our stack pointer. And maybe to get this to work, we have to redefine SP as 0. And then we want the value of A star in the A register. And now our A should be pointing at the register number that is stored in SP here. And that's what we want to set to D. And I've just added some comments here to make it more obvious what I'm doing. We now need to increment SP by 1. So let's set A to SP again. And then A star should now equal A star plus 1. I think that should do the trick. Let's check solution. All right, there we go. Not too bad so far. Next level, pop D. Retrieving the value at the top of the stack is called popping a value. Write code which pops the value at the top of the stack and writes it to the D register. The stack pointer should be decreased by 1 when a value is popped. SP points to the address after the top of the stack, so the value to retrieve is at SP minus 1. Okay, so that's important to know. Let's write some quick pseudocode to break it up into 2 steps. So we've defined our stack pointer variable again, just for simplicity. We're going to decrement the value stored in our stack pointer by 1, and then we're going to retrieve the value from the memory address that stack pointer is pointing to and put it in the D register. Pretty simple first step. We are setting our A register to the stack pointer, and then we're decrementing that value that's in the stack pointer by 1. We're setting our A register to the value that's stored in our stack pointer, and then we're getting the value from that memory address and putting that in our D register. That should work. Let's try it. Okay, level successfully completed. Okay, pop A. Write the code which pops the value at the top of the stack and writes it to the A register. Important criteria, the D register must not be affected by this operation. Okay, so here I've just copied the code from our pop D, and the only thing I'm going to change, obviously in my note here, is I want to put in the A register, and instead of A star going into D, A star is going to go into A, and that should work. There we go. Next up, push value. Now we introduce a macro which uses a placeholder. The macro keyword push.value must be followed by a number, e.g. push.value 42. When the macro is used, the placeholder keyword value in the macro code will be replaced with the specific number, i.e. 42. All right, so we already have a code to push a value to the stack using push.d. So we just need to get the value into D. So A equals value, D equals A, and then we push D. Let's check solution. There we go. Push static. Take the current contents of the memory address given by the address placeholder and push it to the stack. So very similar, we're going to use the push.d macro in order to push the D value to the register. So we just need to get the value at the address placeholder into D. So A equals address, D equals A star. And then we push D. Check solution, good to go. Pop static. Take the value at the top of the stack and store it at the memory address given by the address placeholder. All right, so I think we can use our popd macro here pretty easily. So pop.d will pop the value to the D register. So now all I have to do is set the A register to the address, and then our A star value will set equal to D. Check solution. And moving on, push memory. The value at the top of the stack is a memory address. Pop the address from the stack, fetch the current contents of the memory address, and then push this onto the stack. All right, so I think we want to use our pop A macro here. That will pop the address of the stack into the A register. And now into the D register, we can get the contents of A by setting D to A star. And then we just push D back to the stack. Check our solution. Another level successfully completed. And on to pop memory, the last level in this section. Pop to values value from the stack. I think we got another typo there. The second value is a memory address. Write the first value to memory at the given address. So just to clarify, I wrote this little bit of pseudocode. Our first pop will be the value. So what we want to do is pop D to get that value in our D register. The second pop is going to be the address. So we want to pop A to get that in the A register. And now all we got to do is put the value from D into the address of the A register. So we can do A star equals D. And I believe that should do the trick. Let's try it out. There we go. Level successfully completed. And all levels in Stack Machine completed. What I thought was going to be a long, tricky series of levels actually turned out to be not too bad. Really just setting up some macros to make life easier down the road. Next time will be jumps, which is looking pretty short, but I guess you never know. It could be a couple hard levels. We'll find out. See you then.